Hello everyone, welcome to our soil mechanics video lecture series from the Department of Civil Engineering, SNS College of Technology, Coimbatore. In today's session, we will explore a very interesting and practically important topic, modes of failure in infinite slopes. By the end of this video, you will understand what an infinite slope is, its assumptions, various modes of failure, stability conditions, and practical applications. Let's get started. So, what do you mean by an infinite slope? An infinite slope is a simplified model used to analyze long uniform slopes, typically where the length of the slope is much greater than its height. So let's apply design thinking model for the analysis of infinite slopes by applying 5 stages of design thinking. The topics for discussion in this session are: what is an infinite slope, types and assumptions, modes of failure in infinite slopes, stability analysis under different conditions, factors influences slope stability, applications and preventive measures. So you will find infinite slopes in natural hillsides, embankments and earthen fills. The assumption is that the soil properties, slope geometry and loading conditions remain constant over a large extent, hence it is treated as infinite. This helps engineers to analyze slope stability in manageable analytical way without involving complex geometry. So why do we study about infinite slopes? Infinite slopes are common in both natural and man-made environments, and they can fail due to rainfall infiltration, seepage or loss of soil strength. Understanding these conditions help us design safe slopes and drainage systems and also prevent shallow landslides, especially in residual soils. In short, infinite slope analysis helps in evaluating the stability of hillsides and embankments and understanding how water, seepage and soil affect their stability. So the main objective of the topic is to analyze different modes of failure in infinite slope and determine the factor of safety under various conditions like dry, moist and submerged states. This analysis forms a foundation for more complex stability studies later on. Let's now discuss different modes of failure that can occur in infinite slopes. The first one is dry condition. When the slope is completely dry, only the cohesion and angle of internal friction resist the sliding. The factor of safety mainly depends on the slope angle and soil shear strength. Next is partially saturated condition. When a bit of water enters the soil pores, the matrix section provides extra stability. However, this condition is temporary and may change during heavy rainfall. Next condition is seepage parallel to the slope surface. This is the most crucial condition for slope failure. It happens during prolonged rainfall or continuous seepage where water flows parallel to the slope. The seepage force acts in the direction of potential movement, reducing the effective stress and thus lowering the stability of soil. Next, in case of cohesionless or sandy slopes, in purely frictional soils where cohesion is zero, the stability depends only on the angle of internal friction. Failure occurs when the slope of angle exceeds the angle of internal friction. That is, the slope simply can't hold itself together. The last condition is cohesive or clayey soils. Here stability mainly comes from cohesion, but long-term exposure to water causes loss of section, softening and even progressive failure. Hence, even though cohesive slopes look stable initially, They may fail slowly over time due to weathering and seepage of soil. So this is a mind map representing the infinite slope stability analysis and the various factors involved in it. So we dive into curiosity challenge where you have to solve a real-time scenario and to provide a solution. So consider yourself as an engineer so as to design a long earthen embankment for a highway in a hilly region. After continuous rainfall, shallow slips are observed near the surface. The challenge is the slope is made of cohesionless sand and continuous seepage occurs parallel to the slope. So the objective is to identify the mode of failure and propose a remedial measure to ensure the slope stability. Next is assessment. So there are two questions. First question, in an infinite slope, the failure generally occurs due to one of the reasons. Along a deep circular surface, along a plane parallel to the surface, along the base, or vertically downward. So the answer is option B, along a plane parallel to the surface. Second is, which condition is most critical for infinite slope failure? Dry or fully saturated without seepage, seepage parallel to slope surface, or partially saturated? Answer is option C, a seepage parallel to the slope surface. These are all the resources, web resources about slope stability analysis. So thank you for listening to this video. Hope this video is useful, and let's meet again in another video.